Hi, I'm Steve Moore and I'm delighted to present fAIlureNotes to you today. A failure exploration and analysis tool that supports product designers in understanding the limitations of pre-trained AI models. This work is in collaboration with Vera Liao from Microsoft Research and Subramonyam from Stanford University. Recently, companies such as Hugging Face have started to make a large number of pre-trained models available to the public. Pre-trained models can serve as a valuable starting point and significantly accelerate the product development process of AI-powered products. However, such models are often trained on unknown or generic data without consideration for specific application contexts. Thus, it's inherently difficult to assess the downstream performance of these models in early product development stages. AI failures, on the other hand, are often tied to specific user contexts and can create physical, psychological, or financial harm to users. When drafting AI-powered experiences, UX practitioners such as product designers or product managers need to understand the capabilities and limitations of the AI model. However, unfortunately, today designers lack the tools to explore these pre-trained off-the-shelf models in a human-centered way. To address this issue, we present fAIlureNotes, a model behavior analysis tool specifically designed for UX practitioners. The contributions of this work are threefold and include 1. Semi-structured interviews with 10 UX practitioners as a formative study. 2. The establishment of fAIlureNotes in the form of an interactive web application. And 3. The evaluation of our tool with 10 UX practitioners. For our formative study, we recruited 10 UX practitioners via social media and conducted semi-structured interviews with them, each lasting approximately 60 minutes. The study helped us to investigate what practices designers use today to understand the limitations of AI models, but also to derive design considerations for our own tool. More specifically, we learned that model exploration tools should allow designers to test the AI model for different user groups and scenarios in an iterative manner. Also, due to designers' limited technical understanding, model exploration tools should also actively support product designers in understanding a wide range of AI failure modes. Based on this knowledge, we built fAIlureNotes as an interactive web app. Let's look how Eva, an AI-experienced UX designer, would use fAIlureNotes. Eva wishes to design a computer vision-based language learning app, one that is similar to a vocabulary trainer for people who are just getting started learning a new foreign language. Eva opens fAIlureNotes on her web browser and begins to import data from her user research in the user scenario view. fAIlureNotes allows Eva to observe the model behavior for many different user groups and scenarios, rather than focusing on a few stereotypical personas. Eva has already created two users, Sang and Pamela. Now she adds a third persona for Tom, a city tourist who is traveling to Berlin. Eva also adds two scenarios for Tom on a guided walking tour in Berlin and eating at a local restaurant. For each scenario, she uploads images of objects typically found in these scenarios by dragging and dropping them on the respective scenario. Next, Eva opens the failure exploration view. Eva has access to the users on the left. She selects the DETR object detection model and begins exploring its capabilities and limitations. Eva could start with her uploaded images, but fAIlureNotes also allows designers to generate scenario-specific images. In this case, Eva generates two images of a taxi cab with the text from Taxi in Berlin. She selects one for further analysis by clicking on it. Instead of directly running the model, Eva first annotates her expectations about the model by creating bounding boxes and labels for objects in the image. This approach allows her to define the correct behavior and later analyze differences in the actual model behavior. Eva runs the DETR model for the same image and the model output shows two objects. She notices that the object she labeled as taxi is detected as a car, and another car is detected in the background. In the Model tab, Eva can explore each object individually by hovering over the bounding boxes. To facilitate analysis of image mismatch, fAIlureNotes implements a failure engine that automatically compares model outputs with a manually annotated input. In this case, the system matched Eva's object taxi with a corresponding car in the prediction. The system used a red arrow tag to classify this case as a false detection. The failure engine further explains that taxi is misclassified because it's not within the model's capabilities, indicating this with a blue info tag. Additionally, the system has classified the car in the background as a UD, which is an unnecessary detection. Eva has the option to rate the severity of each failure cases on a 7-point Likert scale, and clicking a button saves the two instances in the database. To support further analysis, fAIlureNotes generates suggestion prompts that Eva can use to generate new images. In this case, taxi is a low-level abstraction for car, so fAIlureNotes suggests looking for a car instead. fAIlureNotes actively guides Eva back to this distribution of the model so that she does not unnecessarily waste time on objects that the model cannot predict by system design. Alternatively, Eva can use the Create Variations feature in fAIlureNotes to augment images. fAIlureNotes generates variations of the images by adjusting brightness, rotation, and blurriness. These variations help Eva explore unknown unknowns and better understand model limitations. Eva now proceeds to the last step, the failure analysis. For each persona, Eva sees a table summarizing the model performance, including how many objects were correctly detected versus how many were misclassified, missed, or unnecessarily detected. Such a disaggregated presentation of failure metrics helps Eva assess how well the model performs for each user group. Additionally, fAIlureNotes provides a zoomable canvas for clustering and synthesizing design considerations based on experienced error. The canvas is populated with all failure instances from the exploration stage. Eva can now group failure instances, add group names, and make notes for UX recovery mechanisms to the canvas using interactive text fields. For instance, she groups a set of cards with rotated images and adds a group name, Model Fails on Rotated Images. As a recovery, she imagines the application detecting rotated images automatically and notifying the user by saying, please retake these images and make sure the camera is straight. After synthesizing her failure patterns and defining appropriate failure recoveries, Eva downloads each canvas as a JPEG image. The snapshot provides Eva not only with valuable design considerations for UI design, but also serves as a boundary object that she can share with her engineering team. Lastly, we conducted an evaluation with 10 UX practitioners to assess the workflow, perceived usefulness, and user experience of our tool. We set the study up as an A/B test. First, participants explored a pre-trained object detection network with Hugging Face interactive model card. Then, we asked participants to do the very same task with fAIlureNotes. The goal in both cases was to create a holistic model understanding and to derive design considerations for our fictional language learning app. We used a mix of quantitative and qualitative methods for our analysis. Here you can see participants' workflow with fAIlureNotes on the left in direct comparison to Hugging Face on the right. With Hugging Face, designers had to switch between different tools. They would search for images on the web or use local image editing software to create image augmentations. This was not the case with fAIlureNotes. With respect to the speed of exploration, participants were slightly faster with Hugging Face than with our tool. However, fAIlureNotes significantly outperformed Hugging Face with respect to the quality of model assessment. 10 out of 10 participants were able to create visual or written design considerations with fAIlureNotes. In contrast, not a single participant was able to do so with Hugging Face. In case you'd like to learn more about fAIlureNotes system architecture, the results of our user experience questionnaire, or discussions about how generalizable our tool is for other machine learning tasks, check out our paper. Thanks for your attention.